Today we are back with the science series of B4M platform. And as you can see, we have Dr. Avi Loeb, a renowned astrophysicist and cosmologist from Harvard. Uh, so today we'll talk about his research that he's currently pursuing. And also we have a couple of questions from you guys that also we'll take. So good morning, Dr. Loeb. How are you?
I'm doing great. Thanks for hosting me. It's a great pleasure.
Sure. Dr. Loeb, to start with, we would like to talk about the bolides research that you have been pursuing last couple of years. Just to give a brief about it, there was an event in 2014. A meteor landed on Earth, and then you happened to research some data a couple of years ago in 2022, and then you actually did a lot of research on that. Could you just describe how you actually came to know about this data, and then what was the research that you have done and where it is today?
Right. So this meteor was an object roughly half a meter in size, the size of a big watermelon, that collided with Earth on January 8th, 2014. And that's a decade ago. And the US government satellites had the sensors that detected the fireball, the explosion, as a result of the friction of this object with air. And they localized it to within a region that is 11 kilometers on a side in the Pacific Ocean, about 90 kilometers away from Manus Island in Papua New Guinea. And they put the data on this meteor in a catalog that NASA compiles with the Jet Propulsion Lab. And 5 years later, I noticed the data, and together with my student, we analyzed it and realized that the velocity of this meteor was high, and therefore it should have arrived from outside the solar system. It was moving faster than the escape speed from the sun. And so we wrote a paper about it, and the US Space Command looked back at their data and confirmed that indeed the velocity of this meteor, based on the fireball that was detected by sensors on US government satellites, that indeed the velocity was above the escape speed from the solar system. And moreover, based on the measurement, it became clear that the object was moving faster than 95% of the stars near the sun. And also, the government released data about the light curve of the fireball, indicating that it exploded only in the lower atmosphere, 20 kilometers above the ocean surface. And that meant that it was tougher than even iron meteorites. It was tougher than all meteors, 272 of them in the NASA catalog over the past decade. Tougher even than iron meteorites. And so that suggested that it's very unusual. And to me, it illustrated the possibility that it might be artificial in origin, because imagine Voyager, our own spacecraft, colliding with a planet like the Earth. It would have appeared as a meteor of unusual material strength and unusual speed. So I decided to lead an expedition to retrieve materials from the meteor site. We went to the localization box of the Department of Defense, and we hired a ship called the Silver Star, and we built a sled with magnets on both sides that we put on the ocean floor and collected tiny particles the size of a grain of sand, less than a millimeter in size, that could have melted off a meteorite in that location. We found 850 of them. These are called spherules. And out of those, about 10% appeared to have a composition that was never reported before in the scientific literature. It took us 8 months. I brought those materials to the laboratories of Professor Stein Jacobson at Harvard University, a world-renowned geochemist, and he has a mass spectrometer, he has an electron microprobes, and I also shared the sample with Dr. Roald Tagel at the Bruker Corporation in Berlin, Germany, and it took us 8 months to analyze those spherules, and we found a population of spherules, about 10% of the entire sample, that has unusual composition with some elements like beryllium, lanthanum, uranium, up to 1,000 times more abundant than in the primordial materials that made the solar system. So that is an independent piece of evidence that we are analyzing some material that came from outside the solar system, in addition to the measured velocity of this meteor. And so we wrote an extensive paper that was submitted for publication a month ago. We also had 3 additional research notes. And altogether, it's very exciting, but the limitation is we can only infer the elemental composition, the chemical composition of those molten droplets from the surface of the object. We cannot really infer what the object was. And for that, we need bigger pieces because they would tell us the structure of the object. The molten droplets lost some elements like volatile elements that evaporated during the explosion. So our goal is to have another expedition, hopefully in the coming year. It will be more expensive because we want to retrieve bigger pieces. And for that, we need a video feed so we can see what we are picking from the ocean floor. We need a remotely operated vehicle, an ROV. And so that mission will probably cost a few times more than the original expedition, which was $1.5 million. And altogether, it's very exciting because we are following the method of science. Using the data from the US government, we collected materials, we analyzed them, and that raises new questions that we hope to answer with a future expedition.
Okay, thanks for those details, Dr. Loeb. Now, there are some interesting parts to this story. Like, as you mentioned, that there were independent measurements, one from DOD, another from seismic activity, right? At least those were the activities that you had data about. And you could see the evidence in both of those data sets, right?
Right.
So that's there.
I should say we looked at the public data from seismometers, as you just pointed out, and we found only one that could give useful constraints. It was on Manus Island in Papua New Guinea. And as you know, from one station, the only thing you can infer is the time delay of any sound signal, because the speed of sound is much slower than the speed of light. And just like when you watch a lightning and after that you hear the thunder, there is a time delay because of the slow speed of sound. And the best you can do is infer the distance that gave you the time delay. So from one station, you can only constrain a circle of some distance away from that station. The seismometer itself cannot give you the location of the explosion. So all we did is we found that the seismometer on Manus Island is corroborating the location that the US government provided. But the expedition itself went to the Department of Defense error box, which was about 11 kilometers on the side.
Okay, great. And Dr. Loeb, who is sponsoring this expeditions that you did and now you're again going to do it? Is it from university or some other independent investors?
No, so the US Space Command, the US government, was very helpful in providing the data about the explosion, the location, the light curve. There were 3 detonations separated by 1/10 of a second. All of this data was very helpful for us. And they were trying to provide as much as they can. You know, their day job is national security, the US Space Command, but Nevertheless, the research team there went back to the data and confirmed that the object was at the 99.99% interstellar in origin. So I'm very grateful for the information they gave. There is actually a second meteor that we identified in the NASA catalog, and they are now looking into it and trying to verify whether indeed that one was as well of interstellar origin, as we think it was. So altogether, I'm grateful for that, but they never provided any funding for us. That came from private donation. And we are now in the process of seeking funding for the next expedition. So if there's anyone that listens to you that might be interested in contributing and being on the ship when we do the second expedition, please contact me. You can find my contact information by putting my name on Google. And if you want to read more details, then as you pointed out, you can go to medium.com, Avi Loeb at medium.com. There are more details about the expedition.
Sure, Dr. Loeb. So yeah, that's really a good part, that due to the help from DoD and from US government, so you not only got help, but also credibility that this is government data. This is not some made up data that you are referring to. So this is important because now I'm coming to the controversy part of it. Last month, in fact, this month itself, in March 24, so there was an article in New York Times by Matt Richtel. He interviewed Dr. Ben Fernando, who is a planetary seismologist at Johns Hopkins. It was actually a very, very explosive interview, actually. If we look at the background that you have provided, the claim that he made was actually really different and interesting, actually. What he said that it was a truck, not a meteor. And then again, there are more astrophysicists like Dr. Ethan Siegel, whom I also follow. He also wrote some articles. He referred to that NYT article, and he went on to claim that these could be industrial pollutants. So this is the controversy part of it. So now I want to know your point of view. What do you think about these two claims?
Well, first I should explain that, you may ask yourself, how is it possible that terrorists are so effective at getting into the conversation? And the answer is that it's much easier to destroy a building than to build it. And so, it took us a year to design the expedition. It took us several weeks to go to the ocean and collect the materials. It took us 8 months to analyze the materials with the best instruments in the world. But to try and destroy all of this work is very easy. All you need to do is sit on your chair and come up with all kinds of reasons why one should doubt the results. And it's just like raising dust in the air and claiming that you don't see anything. So the example of Ben Fernando, he was basically focusing on the seismometer data and saying, in principle, the same data, the same signal could have been provided by a passing truck. Now, the thing to keep in mind is that seismometer data did not guide the expedition. It was the DoD error box, but he ignores it. So if you ignore the most important piece of data and you focus on uncertain data, obviously you can argue that the search was misguided, but it has nothing to do with the truth, with the facts. And Matt Richtel, who interviewed him, did not correct, he did not fact check with me or with anyone else that did the research. I had 30 people involved in the expedition, and then a dozen more people involved in the analysis of the materials. He did not speak with any of us. He just, as if it's a gossip column, he ignored the facts. And I wrote to him and said, look, if as a scientific journalist, someone that reports about science, you ignore facts, if that is your new normal, then how can we complain about journalists reporting incorrectly political matters? You know, this is science. You're supposed to at least attend to the facts, to check those. And it's really disappointing for me to see that. And the fact that Ben Fernando made this claim that you cannot trust the US government, let's ignore the data altogether that the US government provided, and just let's focus on a seismometer and say that data is inadequate. But even that, if you think about it, one station cannot give us the location. I mean, we would go in a circle which is huge, like 90 kilometers in radius, and we will never find anything because part of this circle is going through the land. And so it's ridiculous of him to claim that the expedition was misguided by a seismometer, because we did not rely on this seismometer. It was just to corroborate what the DoD provided. So anyway, that is one part. And then Ethan Segal, you call him an astrophysicist, but if you look at his record, first of all, he did not get an academic position. He dropped out of academia and became a blogger. Why? Because he was not successful as a scientist. Nobody offered him a position at a university, so he became a blogger, and he calls himself an astrophysicist even though he doesn't have a single scientific paper that he wrote over the past decade. No paper whatsoever. So the best you can describe him is as a spectator looking at what scientists are doing. He's not doing science. He's not an astrophysicist. That by itself is a deception, a misinformation. To call himself an astrophysicist is just like a spectator in the audience who may say, I'm a soccer player, but that person sits on the trenches, you know, looks at the soccer game and tells the players how to pass the ball. How dare he? I wrote scientific papers. This month I wrote several of them. I wrote more than 1,000 scientific papers. I'm a practitioner of science. I'm an astrophysicist. Why? Because I write scientific papers in astrophysics. He is not. Yet he has the nerve to come out and tell me how to do my science when he is not practicing science, and to claim that he is protecting science. And to me, you know, that is the biggest misinformation that one can give, because science is what scientists do, okay? And I publish scientific papers that are peer-reviewed in journals. He is writing a blog and dismissing, staining. Now, this is distorting the way science is done. It's giving a bad sense of how science is. It's actually very bad for science that people like him are blogging about it, because he doesn't know what he's talking about. He's just spreading all kinds of misinformation. So I wouldn't even, you know, I didn't bother to ever engage with him. You know, there are some people, and my daughter explains it, that when someone becomes famous, that they become haters, and they get their opportunity to get attention by attacking. And it's exactly what you are seeing. Those people like Ben Fernando or Ethan Segal are trying to get to the limelight by making an outrageous claim like this meteor is a truck. But unfortunately, the data that we used to find the meteor had nothing to do with the seismometer. It had to do with DoD, and they are misleading the public. But what can I do? You know, I cannot run around and correct every error that anyone makes. I'm trying to pursue my science to the best of my ability. And this is the approach that the eagle takes. You know, an eagle very often has a crow sitting on its back and pecking at its neck. And instead of fighting with the crow, the eagle rises to the greatest heights where the oxygen level is low, and the crow just drops off the back of the eagle. And so to me, the greatest heights is doing the science as it should be done. And my hope is that at some point the oxygen level will be too low for these critics, and they will just drop off my back. But I do not engage with them directly because, you know, they don't have access to the materials. We are analyzing the materials, and they express opinions. They claim that we found coal ash. And we checked 55 elements from the periodic table and found that it's not coal ash. And they keep making up claim after claim. They said, you can't believe the US government data. The velocity was 3 times too high. It should be 3 times off of what was reported. And I say, this is the US Space Command. They get $30 billion a year as their budget, more than NASA. And they advise the US president about any ballistic missiles headed towards the US. And so if they get the measurements wrong by a factor of 3, it should be a serious national security matter. You can't just write a paper to the Astrophysical Journal and say, the government is wrong by a factor of 3, I don't believe anything they say, without reminding yourself that you should lose sleep at night because you are paying taxes to an organization that is paid $30 billion a year, and they're making mistakes by a factor of 3. Are you really serious about it? And I, on the other hand, accept, they went back to their data, confirmed it. So I follow that data and do the hard scientific work, which is a lot of work. So, my point is we will go back to that place. We will collect even more data, because the only way to improve our knowledge about nature is by doing the scientific work, not by blogging about it and claiming that you are an astrophysicist just because you are discovering the work of other people.
Okay, yeah. Yes, so you explained it very beautifully. And about coal ash, actually, if I'm not scientist, still I know that the elements that you found, they are much heavier that you find in coal ash, right? The concentration of heavy materials or heavy elements is much more in your finding than it can be in coal ash. So
yeah,
definitely it's not coal ash.
That was by orders of magnitude. So when I say, for example, that it doesn't look like coal ash, I'm talking about factors of 10 to 100. Some elements are more abundant in the material that we found than in coal ash by a factor of 10 to 100. And it's not one element, it's tens of them. And when people claimed it's coal ash, it was based on 3 elements. They said, oh, in coal ash, we have a high abundance of a few elements, and they seem to be similar to what you found, and therefore it's coal ash. And we show that it's not the case. And and originally we were told that we will not find anything. And it's just this negativity that bothers me, because it has 2 unfortunate effects. One is young people who are very excited about my work. I gave, for example, a lecture just a few days ago in Sunnyvale, Florida, and the video is available online on my website. And the audience was full of young people, and the organizers said that they never have young people come to the lecture, the public lectures that they have. So I had a book signing event immediately afterwards of my book. And I asked some of the young people, why did they come to my talk? And they said that they're following the work, they're very inspired, they might want to pursue science as a result of seeing what I'm doing. And when the same audience is seeing the negativity, the toxicity from some members of the public, including bloggers and some scientists, it gives them a second thought whether science is really what it's supposed to be, driven by curiosity. And I ask the fundamental question, why is childlike bullying more prevalent than childlike curiosity? We should all be encouraged by anomalous data because it gives us an opportunity to discover something new. And we should be driven by curiosity. So if I'm spending the time and effort to collect materials and data, the approach of some people should not be immediately to ridicule it, step on it, kill it, and move on. It should be, okay, well, that's very interesting. And could you get some more data? Could we figure out this or that? It should be based on curiosity, on sort of a positive approach. But instead, what you see is negativity and toxicity. And that is really unfortunate. The other thing is young scientists who are already engaged in science, they have second thoughts about innovation. If they were to deviate from the beaten path, they would immediately get canceled and ridiculed and put in the town center and get stoned. And if they are having second thoughts about innovation, then progress in science is slowed down. And it's really unfortunate. We are at a time where we have a lot of data, and we should really allow, open-minded research. So I'm worried about this for those reasons. And at this point in my career, I published more than 1,000 papers, 9 books, and I have a very solid foundation to pursue my research without attending to those critics. But young people are much more vulnerable, and it's really an important fight for me to represent the way science is done, also to educate everyone that does not really get it, that this is the way science should be done, by curiosity and and without pretending that we know more than we actually know.
Yeah, sure. So yeah, that's a bigger problem, that not only they're attacking one particular research, but the whole ecosystem, where curiosity is taking the front seat, and they are actually bringing in bullying also into that. So yeah, that's unfortunate. So one question on this, Dr. Loeb. So Matt Richtel, I saw that you have written an email to him as well.
Right.
As I understand, he should have taken your account also, which he has not done, which is against journalistic ethics. Did you get any reply from him recently?
Well, he simply avoided my email by replying and saying, I transferred your email to my editor. So that by saying that, he removed the responsibility off his shoulders. I know that his article was not in print, did not appear in print, because I get the New York Times in print and it was not there. So I'm sure that the editorial board received my complaint. I also wrote a letter to the editor, and I haven't heard back. And what I did hear from people close to the New York Times is that very often when they make mistakes these days, they don't correct them. A decade ago or before that, they had the ethics, the journalism ethics of taking very seriously omission of facts and correcting their stories when they realized that they missed facts. But nowadays, journalists are much more superficial. This is really unfortunate. Even the New York Times, and very often they have a narrative that they want to express, and they already have that in mind before checking the facts, and they will write the article from a perspective of an opinion. It's more of an opinion essay rather than a responsible journalistic report about all sides of the matter. You see that very often in politics. I never anticipate that this can be the case in science, and I'm very disappointed, because it's as if science is a matter of opinion, and they want to entertain their audience. So nowadays, in the United States, you have those bubbles in politics. There is a huge polarization, and each side, each tribe listens to opinions of people that belong to that tribe, without really engaging in a dialogue and listening to both sides of every story. And that enters journalism, and it's really very bad, because it leads to the extremes dominating the conversation rather than people in the middle. And people in the middle are sort of left to worry out of fear of speaking out, because they will be immediately attacked. And I thought it's only politics, but now I realize it's also in the context of science. And that's why, the public very often loses faith in even scientists when talking about the pandemic, when talking about various scientific reports. It's a self-inflicted wound when science is not reported about in a reliable way, and also when some scientists just want to get to the limelight by making outrageous claims like a meteor is a truck. That's completely ridiculous and out of line, given.
And also, he exclaimed that, okay, so we shouldn't worry that aliens are invading our hospitals. So this is
Yeah, so
this is also what
he made a joke, and that may be good for a stand-up comedian, but not for a science journalist. I mean, so it shows you that he's trying to joke with the tribe, the members of the audience that he knows he has, the bubble of people who doubt that we may have any counterpart in outer space, that those people who say that they are sure that we are alone and that we are special and unique. And first of all, this is very arrogant. I think one thing we know is that we are not very intelligent. You just check the news and you realize that we are not working with each other. We are engaged in conflicts all the time. So we are not the pinnacle of creation. There is room for improvement. You can imagine another more intelligent civilization out there among the hundreds of billions of stars in the Milky Way galaxy alone, that a quarter of them may have a planet like the Earth, roughly at the same separation, based on what we know right now. And just arguing that Albert Einstein was the smartest scientist who ever lived since the Big Bang 13.8 billion years ago is very arrogant. I think we should check agnostically, and I think it's much more extraordinary to claim that we are unique and special than to assume that something like us existed somewhere else. So what I'm doing is searching for objects that may have arrived to our vicinity from another civilization. And it's a completely new method that was only enabled over the past decade. Since this meteor was discovered, there were a few interstellar objects discovered for the first time over the past decade. So it's a new method because in the past we checked for radio signals, and those move at the speed of light and they go away. So if you're not, it's just like waiting for a phone call. If you're not waiting at the right time, you will not get it. With objects, these objects are bound by gravity to the Milky Way galaxy. They keep accumulating in interstellar space, just like plastics in the ocean. And all we need to do is check our backyard and see, maybe we have a tennis ball thrown by a neighbor. Elon Musk launched his car, the Tesla Roadster, in 2018, and it's as a dummy payload on the Falcon 9 launch. And it's now moving in an elliptic orbit around the sun. And imagine another entrepreneur from an exoplanet doing the same. It may well be that space is full of trash. And I'm sure that, the same astronomers that criticize me, if they were to see a car from an exoplanet, they would argue it's a rock of a type that we've never seen before, or they would argue the data must be wrong.
Correct. Yeah, so we have to be curious. We have to keep our eyes and ears open. That's what a scientist must do, I think. Yeah, very well explained, Dr. Loeb. So now we also have a couple of questions from our audience.
Please go ahead.
Let me share. Okay, so here we go. I hope you can see it now.
Yes. What is the validity of the? Yeah, go ahead.
So your first question is actually a small question, but I want to extend the question because there was actually a discovery by James Webb Telescope that after 300 million years of Big Bang, they found a galaxy which was a well-formed galaxy. So that poses a question: is Big Bang theory correct or not? If it is correct, then how that galaxy was able to form in 300 million years, which it should not be able to. So yeah, any reflections on that, Dr. Loeb?
Yes, so indeed the Webb telescope discovered very bright galaxies hundreds of millions of years after the Big Bang. And it raised the question, how do you get such bright galaxies so early? And I should explain that what we see is light emitted by stars. But the usual interpretation is that the stars over there, are roughly the same as the stars that we find today in the present day universe, in the Milky Way galaxy. However, theoretical work that I was involved in and that, started about 30 years ago, about the first stars in the universe, the first galaxies, indicated that the first generation of stars those stars were more massive, much more massive than the sun, maybe 10 to 100 times more massive, because the primordial gas from the early universe did not have heavy elements. It had mostly hydrogen and helium, so it could not cool as efficiently as the present day gas that has heavy elements that came from stars that existed until now and exploded. So as a result, you end up with clumps of gas that are more massive, that make the early stars. And massive stars are much more efficient factories of ultraviolet radiation. So they produce much more light per unit time, and then they die after a short while. They're just like stars in Hollywood that, you know, shine very brightly for a short while and then die. And so it's quite possible that what we are seeing is a different population of stars, the first generation of stars that were far brighter in those early galaxies. It has nothing to do with the Big Bang, just with the process of star formation in the first generation of galaxies. And the Big Bang itself, you know, has a lot of support. First of all, in 1963, a year after I was born, the cosmic microwave background was discovered. That's the heat, the light that was left behind from the hot, dense, early phase of the infant universe, the early universe, that gave a validation to this idea that the universe started hot and dense. And then since then, we measure the abundances of elements in the universe, and they are consistent with an early time in the first few minutes after the Big Bang, where those elements were cooked. The light elements like deuterium, helium, and lithium, those elements are in the correct proportions to what you expect from the Big Bang. And then, you know, we see the structures like galaxies and the distribution of galaxies on very large scales. They are all consistent with gravitational growth of small inhomogeneities that existed in the early universe and became the objects and the structures that we see today. So there are lots of clues that all hang together. As much as this model is successful, the Big Bang, there are big challenges that we don't know the most elementary things. For example, 83% of the matter in the universe is invisible. We don't know what it is. We call it the dark matter. And in addition to that, the expansion of the universe over the past, the second half of its history was accelerated. And that is as a result of the energy of the vacuum, it turns out. And we call it dark energy. And again, why does the vacuum have some energy per unit volume and not zero energy per unit volume? That's not understood. So I would say, in terms of the ingredients of the universe, the composition of the universe, there are major puzzles. We don't know what the dark matter or dark energy is, what the nature of those is. And so there are, of course, interesting puzzles for the next generation of scientists to discover and unravel. But I would say the overall picture of the Big Bang is quite robust by now.
Okay, so yeah, Big Bang theory is not going anywhere anytime soon. That's a relief. So Dr. Lob, that was question by Rajiv Ranjan, and Charul Shukla also has a question. What do you think about Nick Bostrom's simulation hypothesis?
All right, so I'm fundamentally, I'm very connected to nature. I grew up on a farm, and I just refuse to believe that reality does not exist. And I'll tell you also a practical reason. If you believe that you live in a simulation, you don't take responsibility for your actions because they are all part of a computer simulation. if you have an overdraft in the bank, you don't take it seriously. If you get a D in an exam, a low grade in an exam, you say, oh, it doesn't matter, it's part of a simulation. And this lack of responsibility, I have a problem with that, because you cannot build society on such a notion. People have to take seriously the reality that we live in, because it's similar to taking recreational drugs. Basically, you're living somewhere else, and you don't live in the reality that we all share. And another approach is, the one that the one that is advocated by Meta, the metaverse. You put goggles on your head and you live in a virtual reality. And the problem is, you might be happy, but it's not the reality that we all share. So I, as a physicist, I believe that there is a reality independent of us, that it has nothing to do with the computer simulation. I've never seen a glitch or a bug or pixelization of reality. And so I think there is a reality that we need to figure out. And, that's a wonderful life that is given to us to understand better the world that we are born into. I visited the hometown of Nicolaus Copernicus last month. I was invited by the Polish government, celebrating 550 years to the birth of Nicolaus Copernicus. He realized that the Earth is not at the center of the universe, that the sun is at the center of the solar system. It's really wonderful once you realize something like that. And the next Copernican revolution that I gave a keynote speech about is that we might not be at the intellectual center of the universe. To me, that gives a meaning to my life, to search for a partner, to search for a neighbor. So a lot of questions that we still have unresolved, but that's the whole point, that of giving us a meaning to our life. And I don't want to believe that I live in a simulation, because that would take away the responsibility that I
charm
have.
of life. Yes, responsibility and charm and excitement. Yes, it will take away everything if we keep on believing. And that's the right perspective. I think interesting perspective also. Okay, Dr. Loeb, so thanks for that answer. So that was from our audience. To wrap it, Dr. Loeb, thanks a lot. You gave us more time that we agreed for. Thanks a lot for that. To end it, I would just say that I hope and I wish that childlike curiosity is prevalent and childlike bullying is not that much prevalent. That's my wish.
Thank you so much. And to the young people listening to us, never pretend to be the adults in the room.
Sure. Thank you, Dr. Loeb.
Thank you for having me.